Hello everybody and welcome back. In this lecture, I'm gonna show you how to filter traffic by TCP or UDP ports. This is a very common task when developing a firewall. You can match by a single port using the match option --d port, which comes from destination port, or --s port, which comes from source port. It's mandatory to specify TCP or UDP protocol using -p match option, otherwise you'll get an error. Keep in mind that there are ports in the packet header only if the protocol is TCP or UDP. Other protocols, like for example ICMP, do not use ports at all. In this example, we are dropping incoming SSH packets. It's incoming traffic because the chain is input, the protocol is TCP, and the destination port is the standard SSH port. We assume that there is an SSH server that is listening on port 22. If we want to match by multiple ports, we can write more iptables rules, one rule for each port, or we can use another option, which is -m multiport. There are two other options, --s ports to match by source ports and --d ports to match by destination ports. After that match option are coming the ports separated by commas. Let's take a look at this example. We are accepting outgoing traffic, it's the output chain, to port 80 or 443. This means traffic destined to HTTP or HTTPS servers. Perfect. Let's go to a terminal and see some live examples. From Linux 2, I want to see what ports are open on Linux 1. In order to check what ports are open, I'll use nmap, which is, by the way, a great port scanner. nmap and the IP address of the other Linux machine, 192.168.0.10. After a few seconds, nmap will show us what ports are open on Linux 1. As you can see, there are 4 ports open. 22 for SSH, 25 for SMTP, 80 for HTTP, and 443 for HTTPS. I've flashed all the rules, so at this moment it's an open firewall and all traffic is accepted. This is the state where I'm starting from. In each example I'll show you. There is no rule, and the default policy is set to accept. And I want to drop incoming traffic to port 25. iptables -a input, it's incoming traffic, -p TCP, -d port 25, -j drop. And I am listing the firewall again. We can see the rule here, and there are no packets matched. I'm scanning Linux 1 again from Linux 2 using nmap. I'm executing the same command again. And we notice that port 25 is now filtered. By the way, do you know what is the difference between a filtered and a closed port? A filtered port is in fact an open port, but there is a firewall that's dropping traffic to that open port, and we are receiving no traffic back when sending a packet to that port. In this case, port 25 is open on Linux 1, so there is a process that's listening on that port, but it appears filtered to Linux 2 because packets are dropped. On the other hand, a closed port is a port on which no application is listening. If we send a packet to a closed port, we receive a packet back indicating that the port is closed. That's a TCP packet with the reset flag set. For example, port 55 is closed. So as a conclusion, a filtered port is an open port that doesn't respond back because a firewall is dropping the packets, and a closed port is a port where no application is listening and it responds back with a TCP reset packet indicating that it's closed. Now on Linux 1, if I list the firewall, I'll see some matched packets. There are 2 matched packets. Let's try other examples. I want to block all incoming traffic to port 80. Let's check if port 80 is open, closed, or filtered. And it's open. I'm gonna create a new firewall rule that will block all incoming traffic to port 80. In fact, it's the same rule, just that instead of port 25, I have port 80. I'm listing the firewall, there is no matched packet, and if I scan it again, we see that the port is filtered and there are matched packets. There are 3 matched packets. Let's move on and see another example, which is a very common and useful one. We suppose there is a Linux server and a management station, and we want to allow only the management station to connect to the Linux server using SSH. Or, in other words, we allow a single source IP address to connect to Linux 1 using SSH. In this example, it will be the IP address of the Windows recording machine. All other source IP addresses will be denied. Let's check what is the IP address of this Windows machine. I'm running ipconfig, and we see that the IP address is 192.168.0.112. Okay. For this task, I'm gonna create a bash script, write the rules inside the script, and then execute the script. It's easier to manage the firewall this way. The first line of my script is the shebang and indicates that this script will be run by the bash shell by default. First, I flush the filter table of all chains because maybe I'll run the script many times and I don't want the rules to be appended each time I run the script. iptables -f. We've already discussed about this in a previous lecture. And the first iptables rule will permit SSH traffic from that specific IP address. iptables -a input -p TCP -d port 22 -s and the IP address of my Windows machine. -j accept. This rule is accepting the traffic that is coming from the Windows machine. Now you can imagine that we still need something that will drop SSH traffic that is coming from other source IP addresses. There are 2 possibilities. If the default policy for the input chain is set to drop, it means that the traffic that is not matched by any rule will be dropped by the policy. In this case, we don't need to write another iptables rule. But if the policy is set to accept, then we mandatory need a second rule that drops all incoming SSH traffic that was not accepted till that point. In this example, I said nothing about the policy, so I'll write that second rule. iptables -a input -p TCP minus minus D port 22 minus J drop. I don't specify the source IP address, and that means any IP address. If you want to specify an IP address, you can simply write minus S 0/0. It's the same. Perfect. That should be enough. Let's save the script and make it executable. Before running the script, I want to check that port 22 is open. So I'm scanning it using nmap from Linux 2. It's open. Now I'm running the script. Let's scan the port again. And the port is filtered. The firewall is dropping the packets that are not coming from the allowed IP address. Linux 2 doesn't have the permitted IP address. If we list the firewall, we see there are dropped packets. From Windows, I am opening PuTTY and trying to connect to Linux 1. I'm writing the IP address of Linux 1. And open. And we see that the port is open. Packets are permitted through the firewall. There are 18 packets accepted by the first rule. In the last example of this lecture, I'll show you how to match by multiple ports in a single iptables rule using -m multiport match option. I'll try to block the access to port 80 and 443. I'll write the iptables rules inside the same script. iptables -a input -ptcp -m multiport -d ports 80, 443 -j drop. Take care that there is an S at the end. So D ports, not D port. And I'm saving the script. Before running it, I'll check the state of those two ports. Port 80 and 443. And they are open. I'm running the script and then scanning the ports again. Okay, the host is not responding at all and nmap thinks that it's not up. I'll add -p, an uppercase P, and 0 to avoid probing the server using pings. Now it says that the ports are filtered, exactly what we've expected. There are 8 matched packets by the rule.